Okay, great. Thank you all so much for being here and welcome to YVSC's internship closeout presentations for this fall. My name is Dakota Dolan and I'm the internship program manager as well as the Forest Resilience Projects manager with YVSC. And I'm so excited that this day is here to finally share the work of our 4 amazing interns that we had over this fall term. These 4 individuals started with YVSC and joined our team in the beginning of September, and they've been working for 12 weeks on their projects. At the onset of their time when they were first hired, they were paired with a staff mentor, and together they worked on a project concept that addressed one of our 5 main priority areas, which include waste diversion, resilient land and water, community education and engagement, energy, and transportation. And each of the projects that you see today are completely unique and different from one another. Each intern comes with their own set of skills, curiosities, and ambitions, and we try to match that with the needs of our organization in this moment. So we find it to be a very special and fulfilling experience for these interns that will hopefully push them forward in their careers in sustainability. So before we jump into the presentations themselves, I will have our executive director, Michelle Stewart, come up and just say a few words before starting.
Hello, everyone, and thank you so much for being here on this very important celebration of phenomenal work. This is for YVSC staff and board. It's one of our favorite days of the year. It's a day when we get to really hear inspiration about the hard work that our interns have been doing. I will say that this group of 4 has been very stellar. So get ready to be really inspired and impressed. And this is what the work is. It's about coming together and really bringing our skills and capabilities, ideas, and then bringing them into the service of opportunities and actions on the ground. So Cody gave such a great overview of our internship program, but for YVSC, this is a very important investment that we're making. We really see this as being an important part of empowering the next generation of leaders that all of us need. And so we really look forward to hearing from you and learning from you. And we just really appreciate you being here. And our future leaders are those that we really look to as current partners in this work, and then of course, carrying the torch forward. I would like to acknowledge Cody's amazing leadership with the program. So our internship program, we do have a staff individual who is really serving as a primary point person, a mentor, a confidant, and someone that the interns can turn to for support and ideas as they continue to develop their projects. And Cody devotes a good portion of her time to that work and does such a nice job. So I think you'll really see that fingerprint of her leadership in the program today too, as you hear the presentation. So thank you, Cody, for all you do to lead the program. And before we get going, I just want to underline the importance of this type of work. I think particularly now at this time, the national trend, the message that is being told across the state and the nation is really the importance of investing locally and working together in the climate space. Everything that we do on the ground to reduce emissions, everything we do to build resilience actually makes a very important difference. And so as we hear your projects today, I want all of us to really keep in mind and be empowered by the investments that we are all collectively making in local actions on the ground at a time that it really, really matters. So without further ado, I want to welcome all of our interns. And again, thank you, Cody. It is such a pleasure to have you be part of the organization for the past 12 weeks. And as interns, you now get to have a lifetime relationship with us. So it's always really fun because we get to keep in touch with the interns, and we know that many of them will go on to great things. So thank you all. Enjoy the presentations, and thank you so much, Cody.
This presenter is Emma Hack. So Emma, if you'd like to come up here.
Hello all, my name is Emma Hack, as Cody said, and I'm the other one of the Resilient Land and Water interns from this fall. My project was around soil parameters and cottonwood survival at ReTree sites. So a little bit about me. I'm currently a senior at Steamboat Springs High School in town here, and I'm currently in the throes of applying to college, so thoughts and prayers would be much appreciated. I'm a Nordic skier, I'm a baker, and I'm a really amateur potter, and I really like to read, spend time with my family and friends, and spend time outdoors like most people in Steamboat here. before I begin, I'd like to say a quick thank you to my mentors here at YVSC. So Dr. Stewart saw everything go through, and that was really helpful. And Cody was great, and Ryan helped me provide all the sites. And then outside of the organization, I got to work with the city to select different ReTree sites to sample at, with the various property owners of the ReTree sites, who were generous enough to let trees be planted on their property and then let me come dig around in the dirt later, which was really quite nice of them. And also with CMC to do the actual scientific analysis part of the projects in their labs there. So a little bit of background here. ReTree is, I love the picture. ReTree is a YVSC program that's been engaging the community and the Yampa Valley for 15 years now. So planting narrowleaf cottonwoods along the banks of the Yampa to reinforce said banks and also provide cooling shade to the water. And over 200 people have participated in ReTree every single year. So that's over 3,000 people over 15 years, which is really just an incredible amount of community engagement. And until now, YVSC has never done a soil analysis on ReTree sites. And obviously, soil is pretty important for trees. It's what they're planted in. It determines their nutrient levels, the water holding capacity, and lots of other variables that I got to test for in this project. So my project objectives here were to identify and assess different soil quality parameters. So like pH, different nutrient levels, moisture retention, and soil texture, and to monitor the survival rates of various tree species. So just narrowleaf cottonwoods, actually, concerning the identified soil quality parameters, and then compare the survival rates of the ReTree sites to the soil qualities that I analyzed to identify optimal conditions for planting in the future. So in the field, I got to use a soil core, which is like a large metal bar with a hole in the bottom and a handle on top that you screw into the soil about 6 inches deep. And then you pull that sample up and you take it to the lab and analyze it for all different sorts of properties. And then also at the sites, I used a soil probe to take temperature and moisture content at 3 and a rough triangle around where I took the soil core to get a pretty accurate, and then average it for an accurate reading of the area. So the sites I sampled at were the Zimmerman properties can I have the picture of Elk River, and then Snake Island and Hitchens Island, which was planted in 2022, and the Rotary properties across from the Core Trail and Boardwalk that were planted in 2021 and 2020, and then also the Gay property out on 131 where we planted last year. So survivability indicates a percentage of how many trees survived out of all of those planted. So Elk River Zimmerman sites are not included on this graph I have up here because they were just planted this year. So they haven't been in the ground enough to really have significant data around their survival. And then Rotary 2020-1 had a 0% survival rate. So part of this project was sort of an analysis of why that might be. And all this data was collected by Megan Williams. So a huge thank you to her for doing that because it was the whole basis for my project. So a soil factor that we found that had a noticeable impact on tree survivability was phosphorus. So the samples with a higher level of phosphorus had a higher survival rate, and I rated them sort of according to the testing that we did. So a 4 on that graph, which is on the y-axis, is a sufficient amount of phosphate, and then a 1 is depleted. So you can see that the sites with a higher survival rate on the x-axis had a higher phosphate rating, and the inverse is also true. And this is likely because phosphorus is a vital component of building plant DNA and adenine triphosphate, or ATP, which provides energy for plants. So phosphorus stimulates root development, stalk strength, resistance to disease, cold resistance, and seed development. So it's really important for plants to have. And the way we tested for this was we took a diluted soil water sample and put it in this little box that you see on the screen up here. And then we added a chemical indicator and matched it to the colors on the side there. So another impact that we found was soil texture. Sites with a high survival had silty clay loam soil, which is a soil that allows plants to permeate through the soil without their roots drying out. And low survival rates were associated with loamy soil, which is really heavy and can prevent drainage and can cause root-based diseases and mold to fester on young plant roots. And the way we did this sampling was we put a soil sample in a bottle with some dish soap and some water, and we shook it up and we let it sit there for a week. And then after we let it sit there for a week, we were able to analyze it on this very nice little handy dandy triangle to see what sort of soil texture the soil sample had. But unfortunately, most of the stuff we tested for had really no found impact on tree survivability. So temperature actually makes total sense. I sampled at different times of day, like in the morning, in the afternoon, in sunshine and shade. So temperature was very variable, and it makes sense that it didn't really have any found input because it wasn't a stable variable. pH, please. pH is sort of interesting because it was all in a pretty similar range. So there wasn't like an outlier or a really noticeable factor that had an impact on tree survivability. And then nitrate. And then nitrate and nitrate are interesting because I suspect it was something either in the sampling process or in the sampling equipment that we used, because none of the sites were found to have any nitrate or nitrite, and that seems just highly unlikely. And then here are some more things we didn't have any impact. Calcium was interesting because its presence didn't seem to affect plant growth that we saw. But whether it was present or not didn't determine the issues that we had with tree survivability. And I suspect that might be because it's difficult sometimes for plant roots to access calcium in the soil. So it might not have an impact. Sulfate was strange because only one of the sites had any sulfate that we found there at all, and that was Snake 2020-2. And that was an outlier of some sort, don't really know. And then soil color. Soil color also didn't seem to be an indicator of any sort of survivability thing, but it could be perception errors because you get this little color card and you have to match it to the soil. And I am by no means a soil scientist and really had only a little while to learn about this. So it's probably a bit of research error because color is an indicator of different soil chemical properties, and that's why Munsell color is used in the first place. So some more limitations we had here were soil moisture and water capacity potentially have a range of values that have an impact on tree survivability, but extrapolating isn't wise because we don't have enough significant data to make that make any sense. Another thing is that it was elementary methods. We were just using like pH testing strips and the supplies we had on hand for an already completed soil testing class. So any sort of more detailed, scientifically rigorous methods might have yielded different results. Also, it was a very rushed project because a time frame of 12 weeks in autumn and steamboat is really not that much time, considering after a little while we end up with snow on the ground, and snow on the ground makes it very hard to get dirt. So we weren't able to resample the site, so we only had one sample at the site, so that could have been an outlier. And then also human error could have caused various issues. So my key takeaways for the future. Testing phosphorus and soil texture before planting might improve survivability, and it's fairly easy to do. Soil texture takes a week, but you only have to like look at it twice. And then phosphorus takes like 10 minutes. So it might be an easy indicator of maybe better tree survivability to ensure more success with our ReTree sites. So to accurately determine the impact of soil on narrow leaf cottonwoods, a way more in-depth study would have to be done. So all different ReTree sites, because there are many different ones, different times of year. Some of these sites flood in the spring and the trees are underwater. So how does that impact their survival? Multiple different soil colors from all over the sites in case the ones I collected are outliers, and to get a more accurate reading. And then also more advanced methods would probably yield better results. outside of my little project, I got to do all sorts of different collaborations at YVSC, and I had a lot of fun with it. I got to work at and set up for ReTree events, I think 2 or 3 of those. I babysat at the YVSC soiree, and I had a lot of fun doing that. It was really a great time. I did the Next Generation newsletter and the Intern Highlight blog post. I got to engage with fieldwork through more creative means, which was really, really engaging and fun for me. And I also got to do some social media performances. I got to say some words that I will never say again. So that was fun too. For my personal takeaways, I got to apply lab and class procedure to sampling fieldwork, because in my previous research-based job, I worked in the field and then I sent the samples off to the lab, and I sort of never saw like the analysis process behind it. So it was really interesting to sort of see how the sausage is made and get to do the whole equation of research and see sort of both sides of the coin there. And then I also got to use APA, which I'd never done before, and it was really interesting to learn how to cite sources scientifically. I got to communicate with the general public about sustainability causes through the Next Generation newsletter, which I thought was interesting. There was a lot of things that I'd never done before, like recommending different sustainability stuff. And then I advertised community events and encouraged people to participate through Eco Club and posters in the high school. I got to adapt my former independent research experience for working in an environment with lots of people, and I really liked that. I think a super rewarding part of working in an office is having coworkers and people that you get to talk to. It's not just you in your car in the middle of nowhere, which I really enjoyed. So some acknowledgements here. Megan created all the survivability data, which I really, really enjoyed. All my other interns were great as sounding boards. And then I would also like to credit Quinn the dog for cheering me up every single afternoon in the YVSC office. So here are my references. I've got Chen, Y, Wang, H, Wang. No, I'm kidding. If anyone wants it, you are welcome to take a picture of it. But I don't think anyone needs that. Okay, does anyone have questions? Yeah.
Great, and really impressed. Curious if, I know you weren't collecting data on it, but do you have any like qualitative observations about the differences between the sites that other things that we might want to look at in the future, like presence of older trees around where we planted, the type of grasses that are growing there, any walk away with any just sort of general feelings like maybe that had something?
Yeah, so I thought that originally at the site with 0 survivability, I walked up and I thought it was doing great because it had just been replanted by the high school students this year. And there were so many trees and they were all flowering and I was like, wow, this is awesome. No, but so I saw that sites with like really tall grasses and sort of drier environments away from the river didn't do as well with survival, which makes sense because the grasses are taking the nutrients and they don't have as much water. But I didn't really have any in-depth field observations that I think would make a huge difference there.
Thinking about the landowner that runs that, in fact, have soil. And that first test of last week, did they have a village responsible? And sure, tree success. Current scale, they get soil, the trees are affected. Your research.
No, I actually didn't directly communicate with any of the landowners. So I don't think any of the landowners know about the results of the studies I've done on their land. Mm-hmm.
That they don't use the criteria tree success. They're like, can we mitigate service for tree success?
There was a project that had a drip irrigation that introduced various nutrients to the soil in South Africa in 2011. So it took a lot of money and various funding sources from the government to really restore one hillside. I think the project budget was something like $6 million. So it would be expensive, but it is possible.
I'll just.
Yeah.
First of all, we don't have to. Second is that, I've got recommendations from, that we work with that, just in terms of like, you don't want to introduce too much, additive nutrients to each individual plot, because as soon as like trees being really loving it, oh my gosh, there's so many nutrients here, and as soon as those roots get beyond where you drill them, there's no, and I find and they actually end up well. So yeah, it would be really hard to amend the whole area, and then you have to be careful about over amending just where they're planted so that they're not used to.
Emma, you heard Ryan's ReTree, so that's what you inspired to do this ReTree. I think a great project. The question, so what's next for you? You know, you kind of came to this project with a general interest in sustainability and field work, and you've obviously done a great job with that. But we'd love to hear, you know, how this takes you to your next step, how it's informed what you really want to do next as you're in your search and job application, college application.
Yeah. Part of it depends on where I get into. But I really enjoyed this work, and I've also really enjoyed my water chemical analysis previous job that I had through CSU. So I think it would be really interesting to look at how fertilizer runoff and chemicals in rivers affect trees, sort of combining the two things that I've really enjoyed so far and maybe reaching out a little bit further in that. Thank you.
I was wondering how you figured out your methodology, and did you mimic a different study, or how did you determine the steps you're going to take to do the study?
Yeah, a lot of it was through Cody, because did you teach or were you part of?
Right, I was the lab instructor for the soils course this term, so I kind of finished the lab work that was performed in that class.
Yeah, so all the stuff we did was through Cody's previous expertise.